All right, in this video, we're going to talk about factoring applications, some kinds of word problems where factoring will be used. This says 5.8, but in the newest book, this is actually section 5.7. We're going to start with this word problem. Find the area of a rectangle given that the length of the rectangle is 5 more than twice the width. All right, and here we have a rectangle drawn for us with some expressions. This is coming from the phrase, length is 5 more than twice the width. Well, if we designate the width as x, we know nothing about it. The length will be 5 more than, or plus 5, twice the width, or 2 times x. Now, personally, I would have used w instead of x, but the author of the book here used x for width, and that's fine. So to find the area of the rectangle, we use the formula for area, which is length times width. And you can see him working it out here, but I'm going to go ahead and work it out with you guys over here. If area is length times width, then the area of this rectangle would be 2x plus 5 times x. And to simplify that, we'd have to use distributive property. So x times 2x is 2x squared, and x times 5 is 5x. So the area of this rectangle would be 2x squared plus 5x. Now that's not factoring, that's multiplying. But what exactly is factoring? Factoring is just the opposite of multiplying. So we're going to go to the next page and see where we use the factoring. Okay, factoring application 1. Factoring can be used to find unknowns. Find the length and width of the rectangle whose area is 2x squared plus 5x plus 2. So this time we know the area, but we don't know anything about the length and the width. So it says, in this case, the length is the longer side, so this will be length, and the width is the shorter side. Once the width and the length algebraic expressions are found, find the value of the width and length when x equals 5. Then verify by substituting x equals 5 into the area. So we're going to start here with area. And again, we're going to review what we know about the area of a rectangle is length times width. So if you think about this, these are really just the factors of the area. They're the numbers that are multiplied to give you the area. If we know this expression is the area, we just need to find its factors to find the length and width. So we will factor the area, 2x squared plus 5x plus 2. And because of this 2 here, we're going to use our square root method of factoring. All right, now again, if you don't know how to factor, you're going to need to go back and review a previous lesson. So for the square root method, we multiply the front and the back both by 2. We get 4x squared plus 5x plus 4. That's a 2 there. And then we square root the first term. That gives us 2x times 2x. Put in your signs. And we're looking for factors of 4 that add to make 5. That would be 4 and 1. And then we divide by the GCF. So that leaves us with x plus 2, 2x plus 1. And that is the area of this rectangle factored into length and width. And you can see again in the example here, 2x plus 1 is the length, x plus 2 is the width. So take the area, factor it into length and width. Now, the rest of the question says to find an actual length and width when x equals 5. So we're going to take our expressions here for length and width, and we're going to substitute 5 for x. So if the width is x plus 2, and we substitute 5 for x, we get a width of 7 feet. If the length is 2x plus 1 from here, and we substitute 5 for x, we have 2 times 5 plus 1, which is 11 feet. When we multiply length times width, we will get an area of 77. But we should also get the same 77 just by putting the same x into the area expression. So that's what's over here. This is a check. So if the area is 2x squared plus 5x plus 2, and we substitute 5 for every x, 2 times 5 squared, well, square the 5 first, we get 25. 25 times 2 is 50, plus 25. 5 times 5 is 25, plus 2, and that comes out to be 77. And you can see these are equal, which means that you have the right factors. So we're going to try something similar on this question here. Find the length and width of a rectangular garden whose area is x squared plus 25 feet. So you can see the area marked out right in here. All right, so if area is length times width, we're going to factor the area to get the length and width. So we're going to factor x squared minus 25. And if you remember your factoring forms, this is the difference of squares. So this factors to be x plus 5 and x minus 5. Well, the length is always the longer one. So given the fact that these x's will be the same number, x plus 5 will be longer than x minus 5. So this length will be x plus 5, and this width will be x minus 5. Let's try this one. Oh, wait, we haven't finished yet. Once the algebraic expressions for length and width are found, find the numerical value of the width and length when x equals 10. Then verify by substituting 10 into the expression for area. So we just need to substitute 10 in to make sure this times this is actually equal to this. So if x equals 10, which is what's coming from here, we'll substitute 10 in here for length, and that will give us a length of 15. We'll substitute 10 in here for width, and that will give us a width of 5. So length times width would be 5 times 15, or 75. And then we'll substitute 10 in here. So this would be an area of 10 squared minus 25. Well, 10 squared is 100. 100 minus 25 is 75. And the whole point is showing that these two are equal, which they are. All right, let's try this other example here. Find the length and width of a square play area whose area is 4x squared plus 12x plus 9. The length is the longer side and the width is the shorter side. If it's a square, I don't see how one could be longer and shorter, but we'll see when we factor it. So we're going to start with an area of 4x squared plus 12x plus 9. And this is a perfect square trinomial. If you remember the perfect square here and here and the plus sign here, if you remember that form, you will know that this becomes 2x plus 3 squared, which is 2x plus 3 times 2x plus 3. And this is indeed a square. The length and width are the same. 2x plus 3, 2x plus 3. Now, find the numerical value of the length and width when x equals 6. So we'll just put a 6 in here. So 2 times 6 plus 3. That would be 12 plus 3 is 15. Same thing here. 2 times 6 plus 3 is 15. If we multiply those together to get an area, 15 times 15, we'll get an area of 225. All right, now we're going to take this expression for area and we're going to substitute the same x equals 6 into it. So we'll start with 4x squared plus 12x plus 9, and it should come out to be the same, 225. So 4 times 6 squared plus 12 times 6 plus 9. Don't forget you have to do the exponent first here. So we have 6 squared is 36. 4 times 36 is 144. And 12 times 6 is 72. And when we add all of these together, what do we get? Well, let's write it off here to the side. 144 plus 72 plus 9. That's 15. 12, that's 225. And it matches. So see, that's how we know that we have the right factors back here. All right, factoring application 2. The equation of a person who dives off a 48-foot cliff into a river with initial velocity of 32 feet per second is h equals negative 16 t squared plus 32t plus 48. Okay, a person who dives off a 48-foot cliff is a little bit off, I think, but anyway, that doesn't have anything to do with the math. Okay, where t is the time in seconds and h is the height in feet. So the height in feet is dependent on how long, or the time, since the person flew off the cliff. So negative 16 t squared plus 32t plus 48. When will the diver hit water, or when will his height be 0? So we're going to substitute 0 in here for height. And that's going to look something like this. 0 equals negative 16 t squared plus 32t plus 48. And this is an application actually of solving a quadratic equation, where the first step is to make sure it equals 0. So you can see the author, he just reversed the equation. That's perfectly fine. You can put the expression on this side and the 0 on that side. It looks a little bit more natural that way. Negative 16 t squared plus 32t plus 48 equals 0. And then the next step is to factor the trinomial. Well, this trinomial first has a GCF of 16. All of these terms are divisible by 16, and we're going to get the negative off. So we're going to first factor out a negative 16. That will leave us with t squared plus 2t. That's not a plus, it should be a minus, because we factored out a negative sign. So it's t squared minus 2t minus 3. And then, well, this is just a GCF, so nothing's happening with that. But this trinomial here is a standard trinomial that we can factor. So we'll factor that. So we'll have t times t, a minus and a plus, and factors of 3 that subtract to make 2 would be 3 and 1. And we're still trying to solve for t here. And if you remember in the lesson where we solved quadratic equations, we took each factor, we made it equal to 0 to make those little equations. Now, negative 16 can't equal 0. Since there's no variable out here, this is not going to be part of your solution. But both of these factors will be. So we'll have t minus 3 equals 0 and t plus 1 equals 0 from here and here. And then we can solve each of those little equations to give us t equals 3 and t equals negative 1. Now, in the context of this question, when will the diver hit the water? So this is time in seconds. The diver will hit the water when they've been diving, when they've jumped off the cliff after 3 seconds, or after negative 1 second. Well, negative 1 doesn't make sense in the context of this question, because we can't go backwards in time, negative 1 time. So this one is going to be discarded, just because a negative when we're talking about time just doesn't make sense. So the diver will hit the water at 3 seconds. All right, here we have another diver here, another crazy person. The equation of a person who dives off a 64-foot cliff, okay, this one's even more crazy than the last one, into a river, I hope it's a deep river, with an initial velocity of 0 feet per second. H equals negative 16t squared plus 64, where t is the time in seconds and h is the height in feet. When will the diver hit the water? Well, he's hitting the water when his height is 0. So we're going to substitute 0 again for this h. So we'll have 0 equals negative 16t squared plus 64. And again, just like on the previous page, when you switch these around, it just looks a little more natural. Negative 16t squared plus 64 equals 0, but it's still a quadratic equation. and we're still going to factor and solve. All right, so the first step to factoring any expression is to look for a GCF, and of course, we're going to take this negative off. So these two terms are both divisible by 16, so we're going to factor out a negative 16. And when we divide by negative 16, we end up with t squared minus 4. Now, this is a GCF, and because it has no variables in it, it's not going to have any effect on our solution at all, because we're solving for time. So the variables are all inside here. Although it is still part of the factors, I'm going to leave it here. But this binomial here, t squared minus 4, is the difference of squares. So this factors to be t plus 2 and t minus 2. And now that we've got this all factored, remember we take these factors and we set them equal to 0, and we solve for t. So we're going to have t plus 2 equals 0, and we're going to have t minus 2 equals 0. So this becomes t equals negative 2. And then when we do t minus 2 equals 0, we have t equals positive 2. So these are our two solutions. However, again, just like on the previous page, we're solving for time here. When time is in seconds, when will the diver hit the water? So he will hit the water when his time has been negative 2 seconds or positive 2 seconds. In the context of this question, the negative 2 does not make sense, so we're going to discard that. So the only good solution would be 2 seconds here. Positive 2 seconds. All right, let's try this one down here. The equation of the path of a ball thrown in the air at a speed of 96 feet per second is h equals negative 16t squared plus 96t, where t is the time in seconds and h is the height in feet. When will the ball hit the ground, or when will its height be 0? So we're going to substitute a 0 for height again. So 0 equals negative 16t squared plus 96t. Again, I'm going to reverse it the other way just because it looks more natural. Negative 16t squared plus 96t equals 0, and we're going to factor. All right, we're going to take out the negative sign, and both of these terms are divisible by 16, but they also both have a t in common. So we're going to divide by negative 16t, and that's going to leave us with t minus 6, because 6 times 16 is 96. And this time, because we have a variable out here in our GCF, this is going to be a factor here in our solutions. We're going to have to set this equal to 0 and this. So we're going to have negative 16t equals 0 and t minus 6 equals 0. Well, when we divide by negative 16 here to solve for t, we get t equals 0, because 0 divided by negative 16 is 0. So this is a good solution. And when we solve for t here, we're going to add 6. And this is a good solution. So we actually have two solutions here. Let's see what the question was. Let's see, the ball is thrown into the air at a speed of 96 feet per second. T is the time in seconds, h is the height in feet. When will the ball hit the ground? Well, when t is 0, this is the beginning. This is at the beginning. So the ball must have started at the ground when t equals 0. And then after another 6 seconds had passed, the ball hit the ground again. So we can say 0 seconds, the ball started at the ground, and 6 seconds, the ball actually hit the ground at 2 different times.